In this video, I'm going to have a look at installing the Anaconda 2023.09 Python distribution on Ubuntu 23.10. You're going to want to start off with a clean installation, and in this case, I've got a previous Anaconda installation, and you can see this when the terminal is open, it says base. So if I go to the home directory and view hidden files, I see I've got this .bashrc folder, and it's got this conda initialization block. So this gives the terminal the additional conda commands, and notice when the terminal's open, it's got this prefix base, which states the Python environment. So if I just go ahead and delete this block, notice that this base is gone and I no longer have access to the commands in the old Anaconda installation. Okay, so if I restore this code block and now navigate to the Anaconda free folder and then the bin subfolder, which is the location of the additional binaries, notice I've got this conda binary. So what I want to do is use this conda binary in the terminal. So I'm going to navigate to the location of the conda binary. So it's in home Anaconda free bin, and then we've got the conda binary, and then we want to use a sub command which is in it, and then we want to tell it that we want to reverse the initialization. And notice that it modifies the .bashrc file, and if I discard the changes and reload, notice that it's removed this conda code block. So the old Anaconda installation is found in this Anaconda free folder. If you've got an Anaconda based installation such as Miniconda, MambaForge or MiniForge, you may have these folders and they should also be deleted. The Anaconda installation leaves behind a large number of configuration files, and essentially if these have bad settings and are left behind, the bad settings will persist and this may be problematic. In particular is the .conda rc file. So if you have this set to use a different channel than the default, you may have problems when you come to update Anaconda, i.e. use the wrong channel and end up with a corrupt installation when you attempt to update. Some of the folders are used system-wide, so they're used by Anaconda applications as well as other Linux applications. So we don't want to outright delete these folders. We only want to delete the subfolders that are associated with Anaconda. So that should be everything deleted that's associated with the old Anaconda installation. I can now go ahead and download the latest installer from the Anaconda website. So in Linux, the installer is a shell file which is essentially ran using the Linux terminal. The Linux terminal uses a programming language called bash by default, and we use the command bash followed by the name of the shell script file to begin launching the shell script. So if I open up the terminal now, notice that it says username at pcname followed by the directory, and the tilde means the home directory. So when the terminal is open by default, it's going to open in the home directory by default. Likewise, if files is open, it's going to open in the home directory by default. So the tilde means home, and I can change this to downloads. So this is equivalent to opening up the home directory and then selecting downloads. Now, in order to select downloads, I can also change the directory to tilde/downloads, and this is going to take me to the downloads folder. Notice if I right click the downloads folder and select open in terminal, I get the same results. So the next thing I want to do is essentially copy the file name. So I'm going to right click the file and select rename, and then I'm going to select the file name including the file extension, and then I'm going to copy. Now I can press Ctrl and C to copy in File Explorer, In the terminal, the shortcut key Control and C closes the currently running operation in the terminal. So the shortcut key Control Shift and C is used to copy, and the shortcut key Control Shift and V is used to paste. So we're going to type in bash, and then we're going to paste in the file name. So this will begin the shell script, and in order to proceed, we're going to need to press enter. This will take us to the license agreement. Press Q to quit scrolling through it, and then type in yes to accept the license agreement. Press enter to install Anaconda in its default location, which is going to be found within your home directory in the Anaconda 3 subfolder. In the next screen, you're going to want to type in yes to initialize Anaconda. Now, unfortunately, the default option here is no, so many first-time users installing Anaconda will press enter here and install it without initializing it. So when I input yes here and press enter, notice it tells me that the .bashrc file has been updated, and it also tells me to restart the shell. So close down the terminal and open it up again. Notice that the base prefix is here, and this means the base, also known as the root Python environment, is selected. And if we go to the Anaconda 3 folder, there's this bin subfolder, which is the binary subfolder containing the binary applications. So what I want to do is just remove the initialization, because many people will have installed Anaconda without initializing it. So what I'm going to do is navigate to this home directory, Anaconda 3 subfolder, and then select this bin subfolder, and then select this conda binary. And this conda binary is going to be used with this command init, along with the option reverse, which will reverse the initialization. So notice that the .bashrc file is once again changed. Okay, so now I can initialize Anaconda. So we're going to go to home, Anaconda 3, then bin, then use conda with the subcommand init. So we notice that the .bashrc file is modified, and now we have the details about the base Python environment. So I'm going to deactivate this Python environment and then use the command conda update conda. So this is going to update the conda package manager, which will in turn update the entire Anaconda Python distribution. So you may want to check that you don't have a .conda.rc file, which may be using different settings from the default. So it may attempt to update the Anaconda Python distribution using the wrong channel, which would essentially create an installation that's unstable. So it's going to go ahead and solve the environment and then give details about all the packages being downloaded, and then the ones that are going to be removed, the ones that are going to be updated, and the ones that are going to be installed. So in general, there should be only a small handful that's going to be installed, a small handful that are going to be removed. Most will be updated. So for example, we can see the conda package manager itself is going to be updated. We can see that Jupyter Lab is going to be updated. We can see that the libmamba solver is going to be updated. So this is essentially part of the conda package manager now. And the data science libraries, NumPy, matplotlib, and pandas are going to be updated. There's only one package that's going to be downgraded, and this is likely being downgraded to a more stable version, or a more stable version that's stable with everything else. So once the update has proceeded, the next thing we're going to want to do is update the Anaconda Navigator. So we're going to use the command conda update anaconda Navigator. And once again, it's going to solve the Python environment and give details about the updated Anaconda Navigator. So I'll input Y to update to the latest version. So now the Anaconda Python distribution is up to date. So if I type in conda activate base, the base Python environment is now reactivated. So if I go to home, Anaconda 3, and then go to this binary subfolder, this is the subfolder which contains all the Python related applications. So if I search for Python, notice I've got Python, Python 3, Python 3.1, and Python 3.11. So if I just launch Python, notice that I get details about the Python version, and then I get the Python prompt. So in order to exit the Python program, I need to use the Python function exit, and this has parentheses, and this takes me back to a bash prompt. And notice when I use Python 3 instead of Python, I get the exact same thing. And if I use Python 3.1, I get the exact same thing. And if I use Python 3.11, I get the exact same thing. So in the past, there was a difference between these because Python 2 and Python 3 were pre-installed in Linux. Python 2 has reached end of life, so all of these are aliases to the same program. And because the Anaconda base Python environment is initialized, the Windows terminal is going to preferentially search for a binary in the Anaconda 3 binary folder over the main binary folder used by the Linux operating system. So when you type in Python, it's going to find this Python in this folder. So we can type in some Python code such as print hello world. Now notice that the Linux terminal doesn't display any syntax highlighting for Python code. So instead of using Python, you're going to get a better experience using IPython, which means interactive Python. Again, there's a version with a 3, but I recommend just using IPython. So now we've got details about the Python version, and then we've got details about the IPython version. So if we type in print, notice that syntax highlighting's been applied for the print function, and syntax highlighting has also been applied for the string. IPython also makes it easier to look up a Python object's docstring using the question mark. So if I type in print question mark, I'm going to get the docstring of the print function shown in the cell output. So IPython has the command exit, which can be used to exit the application, and you can use this in place of the Python exit function. One thing to watch out for when you go back to Python is that the additions made in IPython are not accepted by Python. So if we go back to Python and we type in print followed by a question mark, we're going to be informed that this is a syntax error, that the syntax is invalid. And if we type in exit, it's not going to be recognized. We're going to be told to use exit, i.e. the function exit, which needs the parenthesis. So if I go back to the binaries folder, notice that I've got the binary Anaconda Navigator. Now the Anaconda Navigator is essentially a collection of start menu shortcuts to the most commonly used Python-based binaries. So if I go ahead and launch this, notice that the terminal is going to be busy while this application is running. So if I have a look at the installed applications, I can see I've got Jupyter Lab and Spyder. And to the left hand side, there's an environments tab which is essentially a GUI version of the Conda package manager. And then there's a learning and a community tab. Now, unfortunately, the community tab doesn't really mention GitHub, and a lot of things have moved across to GitHub. Now, unfortunately, when you launch Anaconda or an Anaconda-based application, you're going to get a driver error. And this is because one of the libraries is out of date. So if I have a look at the latest version of this library on the Anaconda channel, notice that it's pretty old, and it's much older than the current version on the community channel. So in general, it's not recommended to install packages from the community channel into your base Python environment, which should only use packages from the Conda channel, which are tested by the Anaconda company for stability. So I would basically just live with this error and not proceed with this update. However, I just want to demonstrate that the reason for this error is because this library is old. Hopefully by the time you're watching this video, Anaconda have already updated this library to the later version, and it should remove this error when you update Anaconda. So now there's just a Qt warning stating that we're using Wayland, which is the current display driver model for Ubuntu and has been a standard for the last 2 years. So hopefully this warning will also be removed in a later update. These warnings don't affect the functionality of the Anaconda Navigator, so they can just be ignored, but it's better that the Anaconda team update the Anaconda Navigator to remove these errors in the future. So Anaconda is quite tightly integrated with the Jupyter project. Now, Jupyter is actually an acronym for Julia, Python, and R. So it's essentially environment where you can type in Julia code, Python code, or R code. And just to keep the acronym nice, they're using et, which is Latin for and. So by default, the Anaconda Python distribution will use Python as the default kernel. But you can have a look at the kernels by using Jupyter kernel spec list. So we can see that we've only got this Python 3 kernel in the base Python environment. So if I launch this Jupyter Console binary and select the kernel as being Python, which is going to be the default, then notice that I get details about the Python version, the IPython version, and I've also got details about the Jupyter Console. So Jupyter Console and IPython are essentially identical when the Python kernel is used. There is also the Jupyter QTConsole, which is generally pronounced QTConsole, and it uses the Qt GUI framework to basically recreate the console. So this allows the docstring to display as a pop-up balloon when Shift and Tab are pressed. And graphics such as plots are also handled differently in the Qt console. There's also some other options such as saving the session to a HTML file, so you can essentially view it in a web browser and email it to someone. So we can exit the Qt console in the same manner. And notice that the normal Linux terminal is busy while the Qt console is running. So once the Qt console closes, the terminal should show a new prompt. And we can have a look at using Jupyter Notebook now. So Jupyter Notebook is essentially a browser-based implementation of the Python console. So instead of being written using Qt, it's written using JavaScript. So Jupyter Notebook has a file explorer, and this can be used to create a new text file. So a text file is just a standard text file. You just add text and you have no formatting at all in it. So we can go ahead and save this. And if we open up files, we can see that the text file is in Documents. And the Python script file is essentially a text file that has a different file extension, a .py file extension. So we can go ahead and select new file, and we can just go ahead and change the file extension from .txt to .py. So we just call this script.py and go ahead and open it. So when we begin typing, we see that syntax highlighting has been applied, and we can create a very basic Python script file and save it. Notice that we can go ahead and open this in the text editor, and the Linux text editor by default also applies Python code syntax highlighting. So within Jupyter Notebook, we can open up a terminal. And this is basically a bash terminal, so we can change the directory to Documents, and we can use the Python program and supply the script file as an input argument. So this will essentially run the script file and then close the Python program, showing a new bash prompt once the script has been executed. So the main feature of Jupyter Notebook is notebook file. So a notebook file can have Markdown or code cells. So Markdown allows basic formatting of text. So for example, we can create a heading and we can create italic and bold text. And we can create code cells, which are essentially IPython cells. If we press Shift and Tab, we can see the docstring display as a pop-up balloon. And if we press Tab, we can see a list of identifiers that follow the input prefix. If we select File and Save, we can save this notebook file. So the file is called untitled.ipynb. So let me just rename it to something more sensible, such as notebook.ipynb. So I can see this in File Explorer, and if I open this in the text editor, it looks a bit funny. And the reason it looks a bit funny is because it's essentially typed using JavaScript, and it's using JSON to supply the data. So here we can see that the cell type's code, and here is the code that's been input. So in general, we don't want to open up the file using File Explorer in the text editor. We instead want to open up Jupyter Notebook and then open up the notebook using the File Explorer within Jupyter Notebook. And then we want to restart the kernel and run on the cells. So if I close the tab saving all changes, basically now all the tabs for Jupyter Notebook are closed. However, notice that the terminal is still busy. So what's actually happening is it's running a server in the background, and the visual elements of the server are displayed in the browser. So we need to press Ctrl and C to cancel this currently running operation. And then this takes us to a new bash prompt. Let's now have a look at Jupyter Lab. So Jupyter Lab is essentially a newer version of Jupyter Notebook. So to the left hand side we've got the file explorer, and we can collapse it and expand it as we need it. And we can go ahead and open up the Python script file. So I can right click the Python script file and select Create Console for Editor. So this allows me to have a look at identifiers within the Python script file. Generally it works a bit better in the IPython console itself. So here you would test a line, and then when you're happy with the line you can copy and paste it into the Python script file. So pressing Shift and Tab will display the docstring. And I can select Run to run the selected code, or I can select Run to run all the code. So since we've got a file explorer to the left, what I'm going to do is go to the Anaconda 3 subfolder and then have a look at the lib subfolder. So Python's compartmentalized into a lot of separate modules, and these are stored in the library folder under the Python version. So notice that we've got this datetime.py file, which is a Python script file. And if we type in import datetime, what we're actually going to do is import this file. So if we type in datetime dot followed by a tab, we view a list of identifiers. We've actually got other identifiers called data model identifiers. So if I type in underscore and then press tab, I see these data model identifiers. So the file gives the actual location of the file, and we can see that this was this datetime.py script file. For more complicated modules, they are essentially stored in a folder, and when the folder is imported, this special data model _init_.py file is imported. Third-party libraries are found in the site packages folder. So the most commonly used third-party libraries are NumPy, Pandas, and Matplotlib. So if I go to the NumPy folder, notice that it has this _init_.py initialization data model file. And this is the file that's referenced when NumPy is imported using its normal alias np. So NumPy is a large library and has submodules, and some of these are again found within their own subfolders and have their own initialization data model file, which is imported when the subfolder is imported. So another common library is Pandas. So if we import Pandas using its standard alias pd and have a look at its file, we see that we're using this initialization data model file. If we have a look at Matplotlib, we can see that we've got this initialization data model file. So if we import Matplotlib and have a look at the file, we can see that this is the initialization data model file. Now normally we don't use the full Matplotlib library, we use a module called pyplot. So this is why we type in import matplotlib.pyplot as plt. And so when we type in plt.file, we reference this file pyplot.py found in the Matplotlib folder. So we can update the Python script to import NumPy as np, to import Pandas as pd, to import matplotlib.pyplot as plt, and now we can use items from these libraries. So if I press np dot, I should see a list of identifiers. Now it's a bit ropey in the script editor, and it's more reliable in the IPython console. And this is essentially because the code needs to be ran in the IPython console for the identifiers to display. So if I run this code, now I can have a look at y. And if I type in pd tab, I can see a list of identifiers from the pandas library. And if I type in pd.dataframe with open parenthesis and press Shift and Tab, I can view the doc string. So I'm just going to create a very basic data frame, and I can view the data in the data frame using the cell output in the IPython console. Finally, I can have a look at using the plot function to plot the y data with respect to the y data. So notice that this plot displays nested in this IPython cell. So I can go ahead and just save this Python script file. And now I can create a new terminal. So the terminal is going to open in the current directory shown in the File Explorer. So let's just move this to Documents and reopen the terminal. So if I type in Python followed by the name of the Python script file, then it's going to go ahead and run this Python script file. Now in order to show the plot here, we're going to need to use the show command. And now we see the plot in a separate window. And notice that the terminal is busy until this plot is closed. So in addition to the Python script file, we have a Markdown file. And as we've seen previously, Markdown is important for an interactive Python notebook because it's used to format the text in the notebook. So let's have a look at Markdown in a bit more detail. We can create Markdown headings, we can create italic text, bolded italic text, bullet points, tables, links. We can add code, we can add in a code block. So in a Python project, the Markdown file is quite often called readme.md, and it gives an overview of the project. If I have a look at the navigation tab, I can use it to navigate through the file using the headings. If I right click the Markdown file and select Open Markdown Preview, I get the formatted Markdown in another tab. Markdown can also be used to add a LaTeX equation. So I'm going to use only Office desktop editors to just create an equation. And then I'm going to copy the equation. And I'm going to copy it between two $signs. So that's not in the correct format. I need to change this to linear and then copy the linear view. And now we've got the equation. If I enclose it in double $signs, then I'm going to display it as a display equation instead of as an inline equation. So you can see the difference here. And finally, if I go to the code block, notice that there's no syntax highlighting applied. And this is because I've not specified the programming language, which is Python. So when I specify this, notice that syntax highlighting is applied. So we can insert a link and we can insert an image as a link. So the image can be stored on the web or it can be stored relative to the file. If we just use this web image, we're going to use square brackets for the link address and then parenthesis for the image, and we're going to use the exclamation mark to indicate that we want to show the image instead of just a link to the image. So when you're using images on the web, you need to be a bit careful that you're actually linking to the image. So when I opened this image up in a new tab, then I got a different address, and this one worked. So the Markdown file can be opened within File Explorer and viewed within the text editor. And we can now go ahead and have a look at the notebook file. So the notebook file allows us to add all the markdown that we just added in the markdown file. And we can add Python code as well. So there are some shortcut keys in Jupyter Lab, such as escape and M, which will change a code cell into markdown, and escape and Y, which will change a markdown cell into a code cell. Shift and Enter will run a cell. Alt and Enter will run a cell and insert a blank one underneath it. So we can essentially document the Python code as we create it. So here we see the difference between a print statement and an output. Notice that the quotations remain in the output because this is an actual string that's not assigned to a value, so just displayed in the output, whereas the print statement's always just going to print something, and this is going to remove the string's quotations. So we can import the data science libraries. So we can import numpy as np, import pandas as pd, import matplotlib.pyplot as plt, and we can have a look at creating the same data as before. So if we just create the numpy array, once again, we can press tab to view a list of identifiers, and we can press shift and tab to view the docstring as a pop-up balloon. So we can view a variable in the IPython cell, so we can see what y looks like. And once again, we can create a data frame with the columns x and y. So the column names are going to be x and y, and the data is going to be the x and y numpy arrays respectively. And once again, we can go ahead and plot this. So instead of the plot being displayed in a separate window, it's going to be output into the IPython cell. At the top of the cell is details about the last plot command used. To suppress this, I can use a semicolon. Because this is interactive Python notebook and uses an IPython kernel, we can essentially have a look at the docstrings to the functions that we're using, and we can output these to a cell and enable scrolling for that cell. So this is a very basic example notebook showing the importing of libraries and essentially the most commonly used functions of each library alongside the docstring. So we can go ahead and save this notebook file. Once again, if we open it in text editor, it's now going to look a bit complicated, particularly all the code related to the plot. So once again, we don't want to open this using the conventional way. We instead want to use the File Explorer within Jupyter Lab. and we want to restart the kernel, and we want to restart the kernel and run all cells. So when we close all the tabs, once again the server's still running in the terminal. So we're going to need to press Ctrl and C to cancel. And this closes the currently running operation and takes us to a new bash prompt. In the binary folder is also a binary called Spyder, which launches the Spyder IDE. So to the right hand side, we see that we've got an IPython console. To the left hand side, we see we've got a script editor. So one of the main strengths of Spyder is that it's got this variable explorer, which can be used to explore variables for supported data types, i.e. the most commonly used Python objects. So if we have a look at an integer, a float, a boolean, a string, a tuple, a list, a set, and a dictionary, just bearing in mind that a string is a collection of characters, a tuple is an immutable collection of Python objects, a list is a mutable collection of Python objects, i.e. can be modified once created. A set is essentially a collection of unique Python objects, and a dictionary is a mapping of a key to a value, and the value is normally a Python object, and the key is normally a string. Notice if we make a mistake, the syntax highlighting of Spyder indicates that there's an error. We can run the Python code by selecting the Run button, and if we have a look at the Variable Explorer, we see all the variables that have been created. So the tuple is immutable, so it's all grayed out when we view it. The list is interactive, so we can go in and change things. So if I now go to search and then replace text, I want to replace this generic Python object with the integer instance num. So I'm just going to replace all and rerun the script. So now I can view the collections in a bit more detail and go ahead and change the value of this number if I want. So you should be familiar with the data structure shown. And if I now go ahead and just open up the script file, which was previously created in JupyterLab, you should also be familiar with the ND array and the data frame. So notice that the data science libraries are imported, and if I just type in some codes, identifiers will display using the prefix that I typed, and if I type in a function with open parenthesis, the docstring will display. So the arrays and the data frame can also be viewed in the Variable Explorer because these are commonly used data structures. Notice that these numeric variables also have a color map, which can be used to visualize the pattern of the data. So if I make one of these values very large, then the color map changes to reflect this. If I go to Tools Preferences, IPython Console, and in Graphics, I can change the backend from the default inline to Qt. And when I restart the kernel and run the script, the plot now displays in its own separate window. The Spyder script editor, unfortunately at present, has no support for Markdown syntax. However, we can create Python cells using the hash key for a comment followed by 2 percentage signs, which is an instruction to create a new cell. So there's a button to run the current selection of code. There's a button to run a cell. There's a button to run a cell and advance to the next cell. And then, of course, there's the button to run the script, which runs the entire script as seen before. So let me just go ahead and mess up the spacing in my Python script. So now the code looks really sloppy, and this makes it a bit harder to read. So the code essentially violates pep8. And if we go to the binary folder, notice we've got a binary called autopep8 and one called black. So these are formatters, and if we go to source and format the file or selection using autopep8, notice that the spacing has automatically been corrected. We can go to Tools and Preferences, and then we can select Completion and Linting, and then Code Style and Formatting, and change the formatter from autopep8 to black. So now we can format the code using black, which carries out some additional opinionated formatting. Now, I don't really like black because it preferences double quotations, which is inconsistent to the Python kernel. So I tend to just use autopep8 here. Unfortunately, Spyder doesn't have support for formatter which preferences single spaces, such as ruff. Spyder also lacks support for the import organizer, isort. Spyder also has a debugger. So if I create a new Python script file and save this as script3.py, what I'm going to do is I'm going to create two variables, a and b, and then I'm going to define a function called fun. And this is going to have the input arguments a and b, which are going to be different from the a and b in the global namespace. And the function is going to compute a local variable c and return it. And the function is going to be called, and the return result is going to be assigned to the global variable d. So I can run this code line by line now that I'm debugging it. So notice that I see the variables a and b display, and then the function is going to be defined. So this doesn't display in the variable explorer by default, but we can see that it appears in the namespace now. Actually, I can change the settings by going to Tools and Preferences, and then to the left hand side selecting Variable Explorer. And I can uncheck the exclusion for callables and modules. So notice when I do so that I can see this function object. So this function is defined now, and now when we move on to the next line, we're going to call the function. So we can step into the function call. So now we're in the local namespace of the function, which has been provided the values 3 and 4. Notice that the local namespace of the function recognizes the values 3 and 4, and these differ from the global values 1 and 2. So the local variable c is created, and then when we return this value, we return it to d, and we exit the function, so we're back in the global namespace, and that's why a and b are 1 and 2 respectively. So now let's have a look at using the conda package manager in more detail and the concept of a Python environment. So if we go to the Anaconda 3 folder, we've got this environment subfolder, and we can use the conda create command to create a Python environment by specifying the name. So I'm just going to call it uppercase env. Normally you would use a lowercase name for a Python environment. So let's go ahead and activate this Python environment. And notice now that this Python environment is activated. When I type in conda list, I'm going to search for packages in this Python environment instead of the base Python environment. So I can use conda search to search for a package, and I'm going to search for IPython. And we've got the latest versions available on the main channel, which is the channel maintained by the Anaconda company. So notice that the latest version is 8.15.0. However, if I search for the channel Conda Forge, that there's a later version. So Conda Forge is the community channel. So I'm going to use conda install, specify the channel being Conda Forge, and specify the older IPython version. If you don't specify the version, it's going to install the latest version available from that channel. So details about the changes will be shown, and I'm going to press Y in order to proceed. So now I've got this Python environment. Now notice it's got its own binary folder, and this binary folder is a bit more empty than the base Python environment because we've only installed a small number of packages. The lib subfolder has its own Python version. Notice that it's a newer Python version. It's got all its Python standard modules, which are included by default with Python. And it's got its own site packages folder, which is once again smaller than the Python base environment. So if I use conda list, then it's going to list all these packages, and notice that they're from the channel Conda Forge. So if I now use conda update, specify the channel as Conda Forge, and then use the option all, it will attempt to update all the packages using the latest version from Conda Forge. This should never be used with the base Python environment because it essentially will lead to the uninstallation of most packages, making the base Python environment unstable. Notice if I launch IPython, I've got a new version of IPython. If I open up another terminal and launch IPython, it's going to launch it from base. And I can import NumPy as np from base, but I can't do this in my new Python environment because it doesn't have NumPy installed. This new Python environment can be exported to a file. So I'm going to use the conda environment export command and then specify a file, and the file is going to be in documents. And the file extension has to be YAML, yet another Markdown language. And so if I open up documents, I can see this environment.yam file. So it basically tells you the channels and all the packages installed in the Python environment. If I type in Python list followed by the option revision, I'm going to list the Python environment by all the revisions and the changes made per revision. So what I can actually do is use conda install, specify the channel being Conda Forge, and then I can specify a revision. So for example, if I want to revert back to revision 1, I can input the following. So the conda package manager will solve the Python environment, and then it will inform you about the changes, and we can proceed by pressing Y. So this Python environment is now different from the YAML file that we created earlier. So we type in conda deactivate, we now go back to our base Python environment. We can create a new Python environment from the file. So to remember, the file is in documents and it's called env.yaml. And we want to specify the new name for the Python environment. Otherwise, it's going to use env, which already exists. So now we've got these two Python environments, env and env2. So now I'm going to use conda environment remove to remove a Python environment by specifying the name of the Python environment to be removed. And I'm going to remove env and env2 as they've now served their purpose. I'm now going to create a Python environment for R. So the conda package manager can be used to install Python packages, and it can also be used to install non-Python packages that are typically used for data science. So for example, all of these are Python packages. However, we can also install R packages, which are from a different programming language. For Anaconda installation, conda should always be used instead of Python's native package manager pip, because pip only handles Python packages, whereas conda handles other packages which can sometimes be used to enhance the performance of a Python library, particularly a Python library used for data science and big data. So details about the packages to be downloaded will be displayed, and I'm just going to input Y in order to proceed. So if I have a look at this Python environment in its own bin subfolder, if I search for Jupyter, I've got the Jupyter applications. So let's go ahead and activate this Python environment R. And let's have a look at the available kernels. So notice that now I have a Python kernel and I have an R kernel. So I can launch the Jupyter Console using the R kernel, or I could use the Python kernel. So here we see the R version. So now it's going to recognize R code. So exit's not valid R code, and neither is the function exit. Neither is quit. So to exit R, you use Q, the function Q. If I go ahead and launch Jupyter Lab, then notice when I launch a new launcher, I have the option to select the R kernel for a notebook or console. Each package downloaded by the conda package manager is cached. So this means if you create another Python environment which uses this package, it won't download it again. Unfortunately, on the other hand, it means if you create a Python environment and update it multiple times, you're going to have multiple versions of the package cached, and your installation is going to balloon quite quickly. So you may want to use the command conda clean --all to remove old versions of these cached packages. So in this case, you can see that I've essentially restored about 5 GB, and I've not done a huge amount with Anaconda. A popular IDE not pre-installed with Anaconda is Visual Studio Code. You can use the conda base Python environment with Visual Studio Code. However, if you want to use the newer versions of Python packages from the Conda Forge channel, you can create a new Python environment. The Python environment requires Python and Notebook. However, I would recommend installing all the following Python libraries. The Python environment will be solved. Details about the packages to be downloaded and installed are shown. Input Y in order to proceed. Now the Python environment is created for Visual Studio Code, we can go ahead and close the terminal. Visual Studio Code can be installed using the software store. So just search for Visual Studio Code and install it, and then input your password to authenticate the installation. Visual Studio Code will download and install. When you launch Visual Studio Code, you'll be given options to select your syntax highlighting scheme. In order to use it with Python, you're going to need to install a number of Python related extensions. So the most popular extension is Python, and installing this will also install pylints. Then Jupyter, and installing Jupyter will install a number of Jupyter related extensions. In addition to Jupyter, you're going to want to install IntelliCode. So this will essentially help with code completion. And then if we just keep scrolling through the list, we see isort, which is import sort, and this gives a way of using the isort library within Visual Studio Code. And there's also official extensions for the black formatter and the AutoPep8 formatter, so both of these should be installed. You will also want to install pylint. So all of these are official Python extensions developed by Microsoft. A newer, more capable formatter called Ruff is under rapid development, and there's a Visual Studio Code extension for it as well. So I recommend installing this. Once you've installed the extensions, you're going to want to close Visual Studio Code. Visual Studio Code is essentially project-based. So a project is essentially a folder, and the folder contains the code files and normally a readme.markdown file. So in Visual Studio Code, we want to open this folder, and then in order to run the code, you're going to need to select yes, I trust these offers. Pressing Ctrl Shift and P will open up the command palette, and what we want to search for is Python select interpreter, and then we want to select the Visual Studio Code Python environment, or if you've not created this Python environment, you want to select the base Python environment. So notice when we open up the Python script file in Visual Studio Code that if we type in plt dot, we see a list of identifiers. And Visual Studio Code is much better at displaying identifiers than the other IDEs previously examined due to Microsoft's IntelliSense. If we type in a function with open parenthesis, we're going to see the docstring display using a pop-up balloon. So we can go ahead and run this Python script file. So one thing to note about Visual Studio Code is the current working directory is the directory of the project. So you've basically got a bash prompt which has the directory of the project using the base Python environment. It then activates the Visual Studio Code Python environment. The Visual Studio Code Python environment then selects the Python from this Visual Studio Code Python environment and then selects the script file. So you've got the full file path to the Python binary and the full file path to the script file. In order for the plot to show, we need to use plt.show. Visual Studio Code is a general purpose code editor and has support for Markdown built in. The Markdown experience is actually a lot smoother than that seen in Jupyter Lab. So moving on to an interactive Python notebook. The notebook file, similar to the Markdown file, has headings, so we can navigate through these. In order to run the code, we need to select a Python environment. So when we select run, we're prompted to select a Python environment. And if we select the Visual Studio Code Python environment, we can then go ahead and run through the cells one by one. So the syntax highlighting in Visual Studio Code is slightly different to that seen in Jupyter Lab. And the code completion is slightly better. Visual Studio Code also has this variables tab, so you can view some of the variables in a bit more detail. It's not as powerful as the Variable Explorer in Spyder. However, it's better than not having a Variable Explorer at all. Visual Studio Code also has debugging, and the debugging slightly better than the debugging in Spyder. So here we can see we've got variables and we've got local and global variables that are the same because we're in the global namespace. We can see we've got special variables, and these are the data model identifiers. Here the function's defined and it's shown under function variables. We can step into the function. So now we see that the local and global variables differ. So the 3 and 4 are the values assigned to A and B within the local namespace of the function. So we can use the debugger in a very similar manner to the debugger in Spyder, but it's a bit more clear cut between local and global variables. If I go back to the Python script file and mess up its formatting again, I can press Ctrl Shift and P to get to the command palette, and I can type in format and select format document with, and then select AutoPep8. And I can also search for organize imports. And use isort to organize imports. So isort sorts out the imports alphabetically, but will group the Python standard modules before any third-party modules. So you're basically going to have two groups of imports, standard libraries and then third-party modules. So you can also use format document with and select black. However, as mentioned, black prefers the double quotations. So instead we can use ruff, and ruff has a configuration file, so we can create one called ruff.toml. And basically we can just copy and paste the settings that we want and amend them as desired. So I can change the quotation style to single, and then I can select format document with ruff. And notice that it's applied formatting but kept single quotations. If I use the command format notebook, it's going to format the notebook using the default formatter, which is black. And black unfortunately preferences the double quotations, which is inconsistent with the Python interpreter. So here you can see you've got double quotations in the cell, but the output value of the cell has single quotations. If I instead use format notebook with ruff, then the single quotations are maintained and the code looks a lot better. So Visual Studio Code also has the option to export a notebook. So if I select export, I can export the notebook into a Python script. So the Python script doesn't support Markdown, so all the Markdown has essentially been converted to a comment. Notice also that cells are created, similar to the cells in Spyder. So if we run the cell, it's going to run the cell using interactive Python window to the right hand side. So we can run these cells one by one. One thing to be careful of is running the script file itself. We'll run it in Python instead of IPython. So if you've got IPython specific code and attempt to run it in Python, you're going to get some errors. Also, because this file isn't saved, we're prompted to save the file. And the save dialogues unfortunately went behind Visual Studio Code. So we need to select the Visual Studio Code from the panel. And then the save dialog displays. So let's just call the script file script4.py. So once saved, the Python script file will execute and then an error message will display, and this is because there's IPython code and I'm attempting to run this using Python. So everywhere there is a question mark, I'm going to need to comment it out. So I can go ahead and run the script file now, and it should run without errors. Okay, so now the script file runs, but the plot doesn't display. So let's just go ahead and show the plot and rerun the script file again. And now the plot displays, and when I close the plot, I'm taken to the next prompt in the terminal. Okay, so the interactive Python notebook can also be exported to a HTML file. Once again, the save dialogues brought to the back. So this HTML file can be opened in the default browser. So it's essentially a static web page. But this small file can be sent across to someone if they want to read your code. The interactive Python notebook can also be exported to PDF. When a notebook file is saved to PDF, there's some difficulties because the PDF needs to be rendered using LaTeX. So if we go ahead and attempt to save this file, we're likely going to run into an error because LaTeX isn't installed. Now, unfortunately, the error message, which gives more details about installing LaTeX, gives different instructions for each operating system. What this means is there's no common installer and no common package which would otherwise be installable using the Conda package manager. The Conda package manager generally simplifies such things across the 3 different operating systems, making it easier to be consistent. Because LaTeX package hasn't been made, the instructions for the 3 operating systems are different, so what works in one may not work in the other, and this can cause some ambiguity. So for Linux, particularly for Ubuntu, which is a Debian-based installation, the LaTeX can be installed using the advanced package tool command which they give. So just open up a terminal and copy and paste the command. So now that the LaTeX is installed, we can export the notebook file to PDF, and now it should render correctly because we've got a valid LaTeX installation. So now we can open the exported PDF file, and it's going to open in the default PDF viewer. And this format is useful when it comes to creating printed notes.